Simple Circuit Projects is about making circuits that are educational. This video is a step-by-step process for measuring the Raspberry Pi Pico ADC linearity. The method is applicable for other processors with analog to digital converters. This project requires a text editor, spreadsheet, and the Arduino IDE. Earl Philhauer's Arduino Pico must be installed. Go to the GitHub webpage and follow the instructions. In addition to the Pico, you will need a rail-to-rail CMOS operational amplifier. We use one of the amps on an MCP 6004, a solderless breadboard, 4 resistors, and 3 capacitors fill out the component count. You will also need some jumper wires. Homemade ones from 22-gauge solid wire are ideal as they are cut to length. The circuit uses two 10K resistors to divide the 3.3 volt supply to 1.65 volts. A 10 microfarad electrolytic capacitor filters noise from the 3.3 volt supply. 1.65 volts connects to the non-inverting input and is used as the operational amplifier ground reference. Two 10 meg resistors are connected in series between logic output D18 and the inverting input. A 0.56 microfarad polypropylene capacitor connects from the inverting input to the output. The op-amp is configured as an inverting integrator with a gain of 1 divided by RC, or 1 divided by 11.2 seconds. When D18 is low, or 0 volts, the input is a negative 1.65 volts relative to the non-inverting input. The output will linearly increase in voltage at a rate of 1.65 volts divided by 11.2 seconds, which equals 0.147 volts per second. It takes 22.4 seconds to ramp from 0 to 3.3 volts. When D18 is high, or 3.3 volts, the integrator ramps toward ground at an identical rate. The linear ramp has a near-perfect slope, and it can be used to compare the linearity of the ADC. We just need to sample the ramp at very consistent intervals. Let's get started. Insert the Pico and MCP 6004 into the breadboard. Add a jumper wire from Pico pin 38 to the minus bus. Add a jumper wire from Pico pin 33 to the minus bus. Add a jumper wire from Pico pin 23 to the minus bus. Add a jumper wire from MCP 6004 pin 11 to the minus bus. Add a jumper wire from Pico pin 31 to MCP 6004 pin 11. Add a jumper wire from Pico pin 36 to the plus bus. Add a jumper wire from MCP 6004 pin 4 to the plus bus. Add a 10 meg resistor from Pico pin 24 to a vacant strip. Add a 10 meg resistor from the same strip to MCP 6004 pin 13. Add a 10K resistor from the plus bus to MCP 6004 pin 12. Add a 10K resistor from the minus bus to MCP 6004 pin 12. Add a 0.1 microfarad capacitor between the plus and minus bus. Add a 10 microfarad electrolytic capacitor between MCP 6004 pins 11 and 12. Pin 11 is the negative terminal. Add a 0.56 microfarad polypropylene film capacitor between MCP 6004 pins 13 and 14. The test algorithm only takes a few steps. The integrator is preset for a positive ramp. After a lowercase r is received, the test starts. Text output indicates the integrator is ramping negative towards ground. D18 is set high. The output of the integrator comes close to ground but will never reach 0. To ensure the ADC reads a value, a threshold above 0 is used. A delay ensures the output swings past the threshold. Text output indicates the integrator is ramping positive towards 3.3 volts. D18 is set low. Once the ADC detects a small positive threshold, the ADC value is sent every 5 milliseconds. Sampling stops when a threshold just under the maximum 12-bit 4095 value is received. Start the Arduino IDE, select the File drop-down, and click on New. Save the sketch as Linearity Tester Pico. Let's start adding code. 2 global variables are assigned. One is for ADC averaging, and the other for timing the sample intervals. The system is configured for D18 as an output and serial communication. 8 ADC readings are averaged to reduce noise. The 8 reads take about 80 microseconds to complete. 1 bit change is 3.3 volts divided by 4096, or 0.8 millivolts. The integrator changes 80 microseconds times 0.147 volts per second, which equals 0.012 millivolts. This is much less than 1 LSB. D18 is set to ramp the integrator to 3.3 volts while we wait for a small r character. D18 is set to ramp the integrator to 0. A start text is sent. A loop waits for the ADC to reach a count of 30. A start text is sent. After a short delay, D18 is set to ramp the integrator to 3.3 volts. The ADC is sampled until the ADC reaches a count of 25. The ADC is read every 5 milliseconds and the value sent. Reading continues until the integrator reaches a count of 4070, which is 25 less than the max of 4095. To program the Pico, connect your Pico to a USB port. In the Tools menu, set the processor to Raspberry Pi Pico. Make sure to select the active serial port. Click on the Upload arrow. After the program compiles and uploads, under the Tools menu, start the serial monitor. Send a lowercase r to start the test. The Pico will indicate the start of the down ramp. It takes a while before the up ramp will start. The up ramp will send samples every 5 milliseconds until the data exceeds 4070. Right-click in the text area. Then, press Ctrl-A to select all the text. Next, press Ctrl-C to copy it. Start Notepad. Select Edit, then Paste. Notepad will now contain the test data text. Scroll to the top. Select the ramping text and delete it. Finally, save the text to a file, run n text, where n is your test run number. Start Excel. Click on Open, then Browse. Go to your folder where the text file is saved. Select File Type as All. Click on your file name, then click on Open. In the Import wizard, click on Finish. Right-click on the A column and select Insert. In the A column, start a series by entering 1, 2, and 3. Select the 3 values. Left-click on the lower right corner and drag down to fill the A column with the series. Stop at the last ADC value. Hold the Control key and select the A and B columns. Select Insert and use the straight line scatter chart. Now add a chart element and choose Trend Line with more options. You want to display a linear trend with the equation shown on the chart. In cell C1, type in the equation using A1 substituted for X. Select and copy the C1 cell. Use the scroll bar to find the bottom of the data. Press Shift and right-click to the bottom C column. Press Ctrl V to paste the equation into the C column. In cell D1, enter an equation to calculate the difference between B1 and C1. This is the error between the ideal line and the measured data. Copy the D1 cell and paste it into the D1 column. Press and hold the Control key. Select column A and column D. Then insert a straight line scatter chart. Modify the chart to your preferences. From the data, it is apparent the ADC has about 8 least significant bits of nonlinearity. The Pico 12-bit converter is specified at 9 bits and it meets this requirement. Some improvement in linearity is possible. You can read about the technique in the reference.